Today we're going to take a look at factoring GCFs and then also factoring by grouping. This is an assignment in your Delta Math, so if you haven't pulled that up yet, go ahead and get that going. So what we're going to do first of all is to factor this expression completely. Now remember, when it comes to factoring, we have to be able to factor out from all terms involved. Now this one only has two terms, but if we had a third, it would have to be the same amount coming out of all three terms. There's a couple of ways we can do this. One way, I know a lot of you in middle school were taught a factoring tree. A factoring tree is another way. It's kind of a longer way of doing this, but it's also one that will consistently work. But if I take my 27 to a factoring tree and I break it down, well, that would be 9 times 3, and then of course 9 is 3 times 3. So the factored version of 27 is 3 times 3 times 3. And the factored version of 24 would be 6 times 4. 6 factors down to 3 times 2. And 4 factors down to 2 times 2. So the thing that is nice about the factoring tree is not only does it show you what they share, it also shows you what's left after you factor. So we see the only thing that these two values share is the value 3. So we're going to factor out a 3 from both terms, and we will drop a parentheses, and the parentheses is going to be what's left after the 3 is factored out. Now I've used the word factoring numerous times. Factoring is the math equivalent of dividing. We're dividing out this version. All right, and then we also are going to take a look at the x's. Well, the factored form of x to the 5th is x times x 5 times. And then x to the 4th power, of course, is x times itself 4 times. So the value you see that we share are 4 x's. So if they share 4 x's, we can factor out 4 x's. All right, like we said, factoring is the same thing as dividing. So when I divide 3 from 27, what I have left is the value 9. I also can double check that by multiplying the values that remained. 3 times 3. 3 times 3, of course, is 9. I could do the same thing over here with the 24. 2 times 2 is 4 times 2 is 8. But I'm going to usually address these as division because 24 divided by 3 is 8. Leave myself a little more space here. All right, we also factored out x to the 4th power. So if we factored out x to the 4th power, the first term had 5 x's, so we took away all but one of the factors. So all that will be left is x to the 1 power. And on the 24, it was x to the 4th, and we factored out all of the x to the 4th. So therefore, there are no x's left to attach to the 8. So this is the factored form of our term, our expression. Okay, on this one, we're going to take a look at what happens when we factor out an entire expression. One thing you need to know is we never factor down to 0. The only way you could divide and get 0 is if the number was 0 in the first place. So we cannot divide our way down to 0. So let's see what does happen. So as we look at these two values, we see that they both share a y squared. So if they both share a y squared, that means we can factor out a y squared. So that's what we're going to do. We factor out a y squared, goes out to the front, and again, that's the equivalent of dividing. So when I divide x squared times y squared by y squared, the y's are now on the outside. So it's just x squared. Now, when we divide y squared by y squared, you know what this is because anytime you divide a number by itself, 5 divided by 5 is 1, 7 divided by 7 is 1. Well, y squared is a number as well. So when we have y squared divided by y squared, we have 1. So the way we would factor this out is y squared parentheses x squared plus 1. And our last slide that we're going to take a look at is factoring by grouping. This is very important that we learn this, is because we are going to use this moving forward in factoring terms with an a value that is not 1. We've yesterday done the factoring with a equal to 1, so now we'll move on to the next part. So with the factoring by grouping, if you have 4 or more terms on factoring, factoring by grouping is generally what you're looking for, especially if you see 4. The first thing you will want to do is make sure that there aren't any like terms, because if they're like terms, this question gets a lot easier. But as you can see, we do not have any like terms. So we are going to group. I'm going to group the first 2 terms together, and I'm going to group the second 2 terms together. And I want you to notice what I do here. Remember, this negative sign is attached to the 6. So I've got to make sure wherever this 6 goes, the negative sign goes with it. So I factor this out. I like to come in here and put a plus sign in here. And the reason why I do that is because I don't want to get mistaken with this being a multiplication question. So as we do this, we are going to factor each of these terms individually. So as we look at the blue parentheses here, we have x cubed minus 7x squared. Well, they don't share a leading coefficient, but they do share x's, and they share 2 of them. So we are going to factor out an x squared. Once I factor an x squared from x cubed, that only leaves me with 1x. And the 7x squared loses both of its x's, so it's just x minus 7. Now here's a big hint for you. With factoring by grouping, one of 2 things is going to happen. Either this parentheses is going to match the other side's parentheses, or we have a term that is not factorable. Those are the only 2 options we're going to have on those. So when I'm done with this, I should be looking at an x minus 7, or like I said, we have something that we cannot factor. So as we take a look at that, sometimes you can use that as a way of kind of guiding where this thing is going. So here's what I mean. If done, and this does factor, we need this to become x, which matches the other one. So I'm going to kind of just make a real brief, like I said, guide here. How do I get a negative 6x to become a regular x? I would have to divide by negative 6. And then I ask myself, okay, does negative 6 go into 42? Which it does. Now, we learned 2 days ago how to factor. You can do that. You do not have to do the little shortcut or whatever you want to call what I did. But like I said, sometimes it might save you some time. So here's the thing, though. We factored out a negative 6 from 42. Again, when push comes to shove, this is just division. But here's what we also need to consider. If I factor out a 6 from 42, what's left is a 7. But I didn't just factor out 6, I factored out negative 6. So when you factor out a negative number, you always have a sign change. So here's what happened. What we needed to happen happened. We have a matching of x minus 7. What we have here is really just a larger combining like terms. So when we when we have 2 numbers that are being multiplied by the same amount and we're adding them, we add them and multiply 1 time. Let me give you a very basic example of what I'm talking about. If we had 2x plus 6x, the way we would handle this is we would add the terms that are being multiplied by. 2 plus 6 is 8, and we would multiply 1 time. Well, that's actually what we have up here. It's just a larger version of this. We added their coefficients and multiplied 1 time. So let's correlate this with the example we're currently working on. We have 2 terms that are being multiplied times x minus 7. So what we're going to do is combine those two terms, x squared, in this case minus 6, and we are going to multiply one time. It's very important that you put your parentheses around your x minus 6. If I had left it without parentheses and it looked like this, only the 6 would be multiplying times the x minus 7, negative 6, which we see, and we would have ignored the x squared. We don't want to ignore the x squared, so the way that we handle keeping that from happen is the parentheses that you see me put around the x squared minus 6. This is a factoring by grouping. You're going to see several examples of these. Make sure that you do get good at this. If you have questions, make sure that you ask. Good luck.